Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad geometry problem, and here we have a nice right triangle ABC in which the length of its sides are the length of the side AB is 32 centimeter and the length of the side AC is 24. And here we have another smaller right triangle which is inscribed in the triangle ABC, and this triangle is DE and B, and here we call the side length DB is X and we call the side length DE is Y. So that here our target is to find the area of the blue shaded region. So here we have, this is the blue shaded region, and we find the area of this shaded region. So that in order to find this area of blue shaded region, here we need to use the Pythagorean theorem. So that by Pythagorean theorem, so here first we focus on the right triangle A, B and C. So now first we focus on this triangle A, B and C, and we apply the Pythagorean theorem on the bigger triangle. And you know that according to this bigger triangle, we have the Pythagorean theorem will be written as in this form: BC square equals to A AB square plus AC square. So this is the Pythagorean theorem according to the triangle A, B and C. This is the bigger triangle, and now we put the values here, and you see that we have the value of AB is 32 and the value of AC is 24, and we can't have the value of the side BC. So here we first find the value of this side BC. So we write it as BC square equals to AB square, and the length of AB is 32 square plus the length of AC is 24 square. And now we simplify the terms, and here you find the square of 32, and you know that it will be equals to 1024 plus square root of 24 equals to 576. And now we add these two values and you get 1600. So here you obtain BC square equals to 1600, and now we take the square root on both of the sides of this equation, and you get the value of BC equals to plus minus 40. But here you know that BC be the side length of the triangle ABC, so it cannot be negative, so that we choose here only positive value. So this is the value of the side BC. So if you focus on this right triangle, then you see that we have this side is BC, so we denote this by this side length by 40. And now here we find the side length of BE. So you know that the side length of EC is denoted by 10 centimeter, and the total side length is 40. So when we subtract total side length by 10, then you get the side length of EB. So that 40 minus 10 equals to 30. So it means that the side length BE is 30 centimeter. And we already denote the side length DB by X and DE by Y. So that here you focus on this diagram and you see that we have two similar triangles. So our first triangle is ABC and the second triangle is DE and B. So here we just write we have two similar triangles. So these triangles are ABC is similar to the right triangle DB and E. So that here we use the angle angle postulate. So according to this angle postulate, uh, we equate the ratio of uh, two sides which make the same angle. Okay, so that here we just write first the we just equate the ratio of the side db and EB is equals to ratio of the side AB and BC, because this angle is right angle and this angle is also the right angle. So according to this right angle, we have DB, the ratio of DB over EB equals to ratio of AB over BC. So we write this ratio here. This is according to this similar triangle. So we write it as dB over BE ratio equals to AB over BC ratio. Okay, so now we just substitute the values, and we have the value of dB. So this is our dB is x, and the value of BE, so this value is 30, and the value of AB is 32 and BC is 40. So we put all these values here and we obtain this is x divided by 30 equals to 32 divided by 40. So here we just simplify the terms and we move this 30 to the right hand side, and we get x equals to 32 multiplied by 30 divided by 40. And here we need to simplify the terms, and you easily get the value of x equals to 24. Okay, by cancellation of these terms, then you easily get x equals to 24. And now here we use another we equate the other equal sides, so that now here we equate the side of DE divided by DB. So these two sides also make the same right angle, so that now we equate these two sides here, so that here we equate the ratio of side DE over the other ratio is dB equals to the ratio of the side AC and divided by ratio of the side AB. So we have these three ratios, and now we put the values of these ratio here, and we get our final answer. So here we have the ratio of DE is y and DB is x equals to 24 divided by 32. And at the above we find the value of x, and we have the value of x is 24 equals to 24 divided by 32. So here we need to make little bit simplifications, and we get the value of y equals to 24 times of 24 divided by 32, and after simplification you easily get the value of y equals to 18. So now we move towards to find the area of the shaded region. So that here you focus on these two triangles, and you see that we have the area of a shaded region. So our shaded region is the area of shaded region is denoted by ADEC. So this is ADEC. This is the area of shaded region. So we find this area of shaded region by if we subtract the area of total triangle by the area of DEB triangle, then we get the area of this shaded triangle. So we have the shaded area is denoted by ADEC, and area of bigger triangle is denoted by ABC, minus area of smaller triangle is denoted by D, B and E. So now we find the area of these regions, and we can just write all these areas here. So we write this formula here: the area of triangle ADEC, the area of shaded region ADEC equals to area of triangle ABC minus area of triangle DB and E. So that here we know that the area of triangle formula is 1 over 2 times of base multiplied by height. And you see that in this diagram we have the area of the triangle ABC is our base is 32 and height is 24, and in smaller triangle our base is x and height is y, and we put the values of x and y. So that in triangle, area of triangle ABC equals to 1 over 2 times of base and height. So our base is 32 and height is 24. And similarly, if you focus on this right triangle DBE, so the base of DBE is 24 and its height is 18. And now we simplify these two terms, and you get this area will be equals to 384 minus this area is 216. So that our area of shaded region will becomes 168 square units. So this is the our required area of shaded region ADEC. And this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.